Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, welcome to our today's webinar brought to you by the Oxygen Alliance. My name is Janet Douglas. I'm a biomedical engineer with the Oxygen Alliance, and I'm glad to be your host today. I'm joining this call from Lilongwe, Malawi, and I would like to know where you're also joining us from by typing in your name as well as your location in the chat. And if you'd like to get any notifications of the Oxygen Alliance events, may you please also type your email in the chat. So today we have a very exciting presentation from the presenters who are coming all the way from Fish and Pekel. So we have Dr. Joanne as well as Flora on the call, who will be presenting and giving us an understanding on humidification systems. So I'd like to ask everyone to be very attentive. If you have any questions on, or you would like to be qualified on certain areas, please just write down your comments or your questions, and then I will take the questions after each and every presenter. We have two presenters. Once the first presenter is done, I'll give you the chance to ask questions based on what she has presented, and then we'll go to the next presenter and we'll do the same at the very end of the call. Without wasting much of your time, I will now hand it over to our first presenter, Joanne. Over to you, Joanne. You can do the introductions and then you go ahead with the presentation.
Fantastic. Hi, everyone. Thank you so much, Janet and the whole team at Oxygen Alliance for giving us this opportunity to present. So yes, my name is Joanne Chalo. I'm a medical doctor, general practitioner with experience working in district and referral. So when it comes to oxygen system and devices, I'm very passionate about it because I know what it means to be in a hospital and have to interact with it. So it's going to be a presentation today around understanding humidification system. Is going to be in two parts where I'll focus a little bit more on the clinical part, because I feel like even for biomeds, one of the things we struggle with when what we see in hospitals is if you don't fully understand how a machine or a system interacts with the patient, it's difficult to know, to make some of these other decisions. So I'm going to start with some of that. And I'm also, join with my colleague Flora, also a little bit about herself when she gets, when it's her time to present. So I'm going to jump in. So I work for Fish and Pekel right now. Fish and Pekel was a healthcare, a medical device company, which is focused on non-invasive respiratory care. So we make CPAP, high flow, and also humidification system. So it's actually pioneered humidification system on ventilators. So all of our therapies that we talk about are really in that they're delivered through active humidification. So I'm going to go straight ahead and give us what is our agenda today. And we are hoping we get enough time to get through all of it. But why is humidification important? Why does it matter in respiratory care? It's really important for us to understand that overview of humidification types, and we'll just really focus on mostly on what we see in our hospitals, and then issues and preventative measures, planning, consideration factors for humidifiers, and then a summary of best practices. So from 3 to down, that will be mostly Flora that will cover that. So when we talk about humidification, what is humidification and what are we trying to consider? So it's important, and I think, and as we go in, I'll keep mentioning numbers. It's important for us to understand what is humidity. Humidity is the amount of water vapor in a gas, and water vapor in a gas form is experienced in terms of absolute humidity and relative humidity. So basically, we're talking about how we deliver, when we talk about humidity, obviously it's in the context of respiratory care. How do we deliver gases to a patient? We need to be able to deliver it as a conditioned gas. And when we say condition, we're meaning adding water and heat. So there are two terms I would want you to remember. And if you get them, I feel like it encompasses the concept of what I'm trying to talk about. There is something called absolute humidity. And absolute humidity really is the amount of water vapor carried in a liter of water. And that is expressed in milligrams per liter. So here, when we talk about, let's say absolute humidity, we're saying at 37 degrees, you have 100% absolute humidity, meaning you have 44 milligrams of water. That is the ability of 1 liter to carry that, to be able to carry that vapor in a vapor form, to carry water. And then we say, what is relative humidity? This is sort of, and it's expressed in percentage. This is the percentage of water being carried relative to its ability in a whole. That is the easiest way I can put it. So let's say its full ability is 100%, but here you can say it is at 22. It is carrying 22 milligrams. So it's at 50% relative humidity and at 37 degrees. Basically a ratio of what is possible to fully carry. And why are these numbers important? Importance of temperature and capacity. When a gas's ability to carry water, basically to humidify, is very much dependent on its temperature. And we'll see a little bit of that as we go on. So as you can see here, this graph, it's an easy depiction that I want you to remember these numbers. As the temperature is increasing, its ability to carry, absolute humidities are increasing, its ability to carry, the amount of water is able to carry also increases. And now, why, again, is it important? Going back to normal physiology, every therapy or device, whatever we are trying to do, we are trying to mimic, a lot of times we're trying to mimic normal physiology. So if you don't understand what's happening in our normal physiologies, you will look at numbers and say, what does the numbers mean? So what does our normal physiology do? What is our human body accomplish in terms of humidifying the gas we take in? So this is a good depiction of, as you breathe in, it could be room, like this is an example of room air. It could be 22 degrees at 7 milligrams of absolute humidity, of basically water content in the air. And as you breathe in, as the air goes down, when in the nasopharynx it is heated, it is filtered, it is heated, and humidity is added. So as the gas travels down until it reaches this point, by the time it gets to your alveoli, it is at 100 degrees relative humidity, 44 milligrams per liter in terms of absolute humidity, and at 37 degrees. And we know 37 degrees, that is our core body temperature. So when we talk about what is optimal humidity, meaning what is that set values where your physiologically gas exchange happens in our lungs. We say it happens at 37 degrees, our core body temperature, 44 milligrams of humidity of water in that gas that we've inhaled, and at 100% relative humidity, meaning it's fully saturated. Now, why is this important and how does it happen? So, like I said, that temperature, kind of the heating, the humidifying happens as the gas goes down from your breathing it in. This is what is happening. Why are these things important? What is this function? We have something called the mucociliary system, which is basically a mechanism to protect our airway. And I think all of us have experienced coffee. And you have what we call these cilia, which are on this, basically the lining of our airway. And you have these cilia, which act like, they're kind of like little hairs, right? So your cough reflex comes from when something is going down, you cough and it beats it up. So for it to be able to function well, those defense mechanisms, it is important for this layer to stay humidified, to stay basically with a lot of fluid in it, and for it to function well. Where it doesn't function well, we see problems. Now, in terms of respiratory support, we've all seen patients on ventilators, right? When you put a patient on ventilator, you're basically bypassing their upper airway. So given all the things we've talked about, what happens to the gas as it goes down, you're giving a cold gas and you'll bypass all this, because 75% of our natural heat and humidity actually happens in that part. So if you're bypassing it, what is happening to the lungs? You're delivering a cold gas, and that ends up affecting the function of the upper airway. So what are some of the things we see when somebody, if we give unhumidified gas, or if we are delivering, if we have an intubated patient bypassing those, that area that has, humidity, what do we see in a patient? We see discomfort. It's very highly uncomfortable. Sometimes we see drying, which leads to nosebleeds. We see thick mucus production leading to VAP, and also increased work of breathing. And so, a note here that I wanted to make, and again, when it comes to infants, they experience that need. So for you to be able to heat and humidify, right? This is a measure of how much energy it uses to just heat and humidify the air you're breathing in. Now, when it comes to neonates, because we already know they need every energy to grow. And if you talk to nurses and doctors, you will find out one of the things we do when a neonate has respiratory distress, we increase their amount of feeding to kind of give them that energy, because 85% of this energy is actually spent on humidifying and adding water and adding it to that gas as you take it down. So if you're giving a baby cold air, they will have slower recovery. They'll have all these other side effects I've mentioned, but also it will affect their growth. Now, how do we inspire gas? We know about oxygen, we know about room. This is room air, and I want you to pay attention to the numbers. So, and the reason why we said with the numbers, medical gas is quite cold. A lot of times is what we say it's at room temperature, right? But it's extremely dry. And as biomeds, you can tell me why. And it also, it has very, very little humidity in it. So it's really extremely dry. So if you're giving it without adding any sort of humidity in it, this is why we see sometimes patients getting bleeding and all that. And then room air, this is what happened, because as a healthy person, your body does all the humidification to get it to this. So how do we get this to this? I'm going to start with this part, which is I'm going to focus on humidification for low flow, and there's different ways to kind of like divide the humidification types. But I thought this would be the easiest one. So when we talk about humidifiers for low flow, we're talking about passive humidifiers, and why is that? Because you don't need heat, right? And we have the bubbler that we all know, which we have an example of here. And what happens is when you have a bubbler, you have a oxygen source. So you push the oxygen through here. And I would like to make a disclaimer here. On this particular part, we say there is industry expertise, but this is not industry expertise. This is more clinical expertise from my experience. So this humidifier, what happens is we give oxygen through here. It goes down. You have what we call a diffuser, and its job is really to break down the bubbles, so that you can increase the surface area for it to interact with the water in the bubbler. And what then happens? That water or that gas, as it leaves to go to the patient, it is carrying some level of humidity. Now, the amount of level of humidity this particular sort of humidifier can give us can only be 15 to 20 milligrams. And also we know this is flow dependent, because as a gas flow increases, its ability, for this particular humidifier, its ability for the diffuser to add, to break it up and really for the gas to interact with the water decreases. So that means at 15 liters of flow, you will not be able to get to 20. But at 10 liters or 8 liters, you are able to get at least to 20 milligrams. And this is also very dependent on brand, but also the lower the flow, the higher the chances that you'll have a little bit more humidity. But the maximum it can give you is about 15 to 20. And then this is obviously unheated, and it is important to use distilled water, because a lot of this going to end up as aerosols into the patient's upper respiratory system. So it's really important. And also for a lot of these bubblers, they will also come with an manual. It's important to read it and refer to it. And then another thing is that we have the passovers, and also the active humidifier that we'll talk about later kind of has the similar, that sort of passover mechanism, but in this one, some have like, there's either a membrane, some sort of a membrane referred to as the wick, and then we also have like a semi-permeable membrane where the gas interacts with like a membrane that is kind of like holds water content and picks up some and leaves to go to the as an output. But we mostly focus on this because of what we see in practice. And when we talk about low flow, what are the different devices? Where do you need that sort of humidifier, and why is it important? So for one, to remember, I mentioned that humidifier can only work at low flow, meaning the maximum it can give you from up to 20 milligrams of water content is also dependent on the flow. So when we say low flow, we all know you start with nasal cannula. If a patient needs more than 6, you go to a face mask. If a patient needs more than 10, a flow of 10, the highest you can go to in low flow is 15, right? A flow of 15. Now, this is still appropriate to use a bubbler. And also, a lot of these patients are not too sick. We also expect, because it's still going through the upper airway, they still can somewhat add humidity to it by the time the air hits the lungs. Now, this is another point. When we talk about heated humidity, which Flora is going to be talking about, so I want you to make a distinction. If you were having invasive ventilation, you should never use passive humidity. You need to use active humidity. When you are having NIV, because you have higher flows, a lot of times you have higher flows, it's important to have active humidification. When you're doing optiflow nasal high flow or high flow nasal cannula therapy, it's important because you're going beyond, and nasal flow is defined as flows that are above 20 liters. And obviously in pediatrics, we calculate based on weight and all that. And I want to make this quick point here where, because it's important for patient comfort, of all the things we've talked about, right? Why it's important to have, humidity. It's important for patient comfort. It's important for normal physiology. And even as you saw, the moment you go higher, you keep changing the interface, right? So how can you tell me you can give me up to 60 liters or 70 liters of high flow through a nasal cannula? Part of it is because you humidify it, actively humidify it. That's the only way it is possible to deliver those high flows at a flow higher than 15, because you're able to humidify. Another one is obviously NIV, as I mentioned, and then a special mention to bubble CPAP. It's important to actively humidify even bubble CPAP when you're delivering it to baby, because of what I have mentioned around physiology. But for babies, it's even worse because it's really underdeveloped. So when they have respiratory distress, they have increased work of breathing. They have they lose their hypothermic. All these different things contribute to them getting worse. So if you're able to give them a therapy that's already where the normal physiology has already been achieved at optimum temperature and humidity, you are more likely to see better outcomes. And with that, I'll take some questions. Sorry, I think I went off like about 2-3 minutes. Back to you, Janet.
Yes, thank you very much, John, for that presentation. I think I'll just hand it over to the audience based on what John was presenting. Like I said, she was supposed to come in with the theoretical side of the presentation, and then Frola will come with the technical part. So if there are any questions, please, you can just raise your hand or you can type it in the chat. Over to you, the audience.
Can I again give you a question, guys? Since it looks like
yes, John.
Oh no, I was going to start calling up people to answer my questions, but no, I think we'll run out of time. But if there's no more questions now, I think it's okay to go to the next person, unless if there are any in the chat.
Okay, all right, there's a question from...
How do you humidify higher flows? So the way we humidify higher flows, and this is the part that, so over 20. So this is the part where Flora is going to jump in and explain a little bit more, because it will show focus on active humidity. But what really, for you to be able to get to optimum humidity, there has to be heating. If you see the part of humidity I've talked about is all passive humidity, so there is no heating. It's just basically the gas interacting with water and somehow picking up some humidity to go. And the maximum you can pick up is like 20 milligrams of water. We said optimum humidity is 44 milligrams. And also that 20 is dependent on a lot of things. It depends on the kind of, on the oxygen you have. It's depending on the sort of setup, is depending on also the brand itself. Now, for active humidity, you need to have heating, and also there will be water going in, but you'll have active humidity, actively heating so that the gas can pick up that. So for high flow, it's the same. If I can quickly show you that picture again. So here, I can't, maybe Flora, you can use your pen now. So there is a humidifier that is attached to within the device. And that device, it is sitting, the humidifier is sitting on the heater plate. And that heater plate, the more, when you switch off the machine, yes, when you switch off the machine, the heater plate starts heating the water, and then it travels through, it's able to travel through that circuit to the patient. So that's kind of how you do active humidification in high flow. And every high flow device will have that sort of setup, should have that sort of, otherwise it's not high flow. I've also seen things in hospitals where somebody took a normal cannula and put it on a 60-liter flow meter and put at 20, saying this is high flow. That is it was very painful. Basically, you can literally damage the patient's upper air because it's a cold gas, painful, and it dries up the mucosa. But that's how you deliver high flow, through a heated system. And Flora will talk a bit more about the active humidity.
All right, thank you very much, Joanne. There are other questions in the chat, but because of time, I think we can just go straight to the presentation and then we'll come back to the questions. So when Flora is done, I will be taking the questions, reading it for you. I don't want you to stress about going back to the chat, so don't worry about it. Thank you so much, Bryson, for that question. I'll now hand it over to Flora to take us through the next part of the presentation. Thank you.
Thank you all so much. Thank you, the Oxygen Alliance and everyone for joining us. My name is Flora B. I work with Joanne at Fisher & Paykel Healthcare. I am a biomed by training, and I am also very passionate about oxygen delivery, specifically active delivery. So I am quite excited to be taking you through the next session, which would be the more technical aspects of things. And then we can ask any questions that you may have towards the end of it. So picking up from where Joanne had left off, we just want to see the commonly used humidification systems that are common in most of our settings in sub-Saharan Africa. And they're mainly divided into two main broad systems, that is active systems and passive. And just as the name suggests, active systems do add heat and humidity to inspired gas, and further upstream, I'll be able to take you through how. And they also have a capability of provision of the optimal heat and humidity that Joanne talked about, that would be very critical for providing oxygenation, especially in the lung area. They're also used in a variety of therapies. So invasive, non-invasive, and high flow therapies, just to recap what Joanne had mentioned. And it's important, and this is in comparison with the passive humidification systems, where you would not find much contraindications in the disease states that it's able to manage, and also different therapies that it would be able to provide. So for just understanding, I'll be using the Fisher & Paykel's MR850 as an example, so that I can take you through step by step on what active humidification would entail. So in contrast, what passive systems are is basically a form of humidification that would use the patient's own effort. So it would use the patient's heat and humidity on exhalation. And in this case, I'm talking of patients who are invasively ventilated, where as they breathe out, a bit of heat and a bit of humidity would be trapped in the HME. HME in full would stand for heat and moisture exchangers, and some would be, combined with a bacterial filter. So some would be a HME combined with a bacterial filter. However, it is used for short-term ventilation. So it's not recommended for long-term use if you have patients who need long-term ventilation. So also for patients who have very heavy secretions, it would be quite ineffective. And for such patients, it's highly likely that you would need very many sessions of suctioning to be able to manage the heavy secretions. Because of the heavy secretions, there's a lot of resistance that is generated. And so you find these patients, because of the high secretion levels, the patient's work of breathing increases significantly. Not only that, but because a HME is actually fitted on the circuit itself, it does contribute to what we call instrumental dead space and general resistance. So what you see is that there's a lot more pressure, a lot more effort that the patient has to do to be able to get the tidal volumes or get the pressure into the lungs as they would need. So basically, because of those factors that I have talked about upstream, it's contraindicated for management of a wide array of patient indications like I would show you. It's also very important that I mention at this point that if you're using an active humidifier, which I will go to in a very short while, is you are not supposed to use a HME with active humidification. Some of the hospitals that I have been to all across sub-Sahara Africa, many of them still use a HME together with the active humidifier, and I will show you why this would be a caution for you to be able to look at. But if you're to compare the two systems, especially looking at ventilation, just to summarize, you can see that because of the dead space, the resistance, and the risks of ETT occlusions, especially with the use of endotracheal tubes or even tracheostomies, you'll find that for treatment requirements that need the long-term ventilation, or you need to do lung protective ventilation, or you even need to give nebulized medication and weaning, there would be a stronger preference towards the use of an active humidifier as pertains a HME. And also for different respiratory status that the patients would get, especially if patients probably have acute respiratory distress syndrome, acute respiratory failure, those patients would be better off managed with an active humidifier if they need to be invasively ventilated as compared to using a HME, a heat and moisture exchanger. So what really delving deeper into an active humidifier, what would it really comprise? So this particular slide that I have put here is just to be able to further educate us on what an active humidifier really does. So the components that it would have is that it would have, let me just use the pen so that I can be able to show you, but it would have this this part here, which would be the humidifier itself, and the humidifier itself comprises of a control and display unit. Now the control of and display unit would be referring to this area here, and that unit does have a display which can be able to show you the temperature that is being delivered to the patient, and also show you the mode that the patient is on. So is this patient on an invasive mode, meaning that they have an endotracheal tube or a tracheostomy tube? And also, could this patient be a neonatal patient? Why this is important is if it is in invasive mode for, say, a neonatal patient, it would be almost a standard of care practice to ensure that the neonate is receiving 37 degrees centigrade 44 milligrams per liter of humidity, just as Joanne mentioned earlier. So it would always be on invasive mode. However, there would be instances where you'd be offering BiPAP or even CPAP, or a mask mode where you'd be using an NIV mask. So because of that, you toggle this button to be able to guide the humidifier on the amount of heat that it would produce in that regard. There's also the power button and the silence button. So this is what would comprise the display unit. Besides that, you have this we call the finger guard. Now, the finger guard is just a guide that would be able to be used by depressing it to push the humidification chamber, which is this portion here. Now, why is this important to have a humidification chamber? Because this is absolutely where all the magic happens. So when you have gas that is coming from any flow source, for example, a ventilator, it would be drawn in, and remember that gas is very cold and very dry. So it would be drawn in by what we call a part of a circuit we call a dry line. And once it gets into this humidification chamber, the chamber itself has sterile water in it. And it's important that I show you that for the chamber itself, it would have, let me just rub this part off so that you're able to see. If you can see my line here, you'd be able to see that it does have a maximum fill line, which is indicated there. So this fill line is very deliberate in terms of its design, in the sense that it would be the maximum line where you would put sterile or distilled water. Recall that I have said sterile or distilled water because there have been many instances in many different countries where we have visited across sub-Sahara Africa, where they would use and unknowingly would use saline or would use medicated fluids like glucose, for instance. Why this one would not be recommended is because the base of the humidification chamber is actually aluminum. So because it is there is heating that is taking place, it would form crystals at the base of the humidification chamber. Now, besides that, you actually would have a series of heater wires and also probes. Now, these two are very much color-coded, and by design, it is color-coded so that ourselves as biomeds and also nurses and also other clinicians would be able to know which probe goes where. Now, we have two of them, and it's important that I share what each of them does. Now, the heater wire that you see here, which is actually yellow in color, the heater wire connects the heated inspiratory limb, which is the one that will deliver the gas to the patient, to the humidifier itself. Not only that, but the heater wire is solely responsible for providing the energy that is going to heat the wires that are inside the circuit itself. Now, in using active humidification, the core principle would be that you have you're using heated wires where you can actually visualize the coils that are inside this specific inspiratory limb. So for some, you'd have heating at the inspiratory limb only, but with others, because of improvement in circuit technologies, you're able to have heating both at the inspiratory side and also at the expiratory side. That is the heater wire. Now the temperature and flow probe, which is actually blue in color, is majorly for doing two roles. And that's why we've indicated here that it has a dual temperature feedback system. Now, the temperature and flow probe is responsible, one, for checking the output of the humidifier in terms of the temperature of the gas that is leaving this humidification chamber. But also it does have another patient end, which is at the end of the circuit, and that one checks the temperature that is being delivered to the patient. So by having a dual temperature feedback system, it then ensures that the gas that is being delivered to the patient is optimal. It has 37 degrees centigrade, 44 milligrams per liter of humidity, and that would be its core purpose. Now, the humidifier itself has its own internal algorithms. It does have a capability of automatically adjusting itself in modifying the heat and humidity that is being delivered to the patient. So besides that, you'd have smart alarms, which I will talk about later as we continue on the same. So in circuits, setting up of circuits, now there are different ways that different settings use ventilation. Some would prefer a single limb setup, others would do a dual limb setup. Now, for a dual limb setup, if I was to just explain one, it would comprise of several different parts of a circuit. So I'll just go over some of them very briefly. So this would be the dry line, which will be pulling in, or rather getting in the gas that will be going into the humidification chamber. The humidification chamber are quite different. Some have an out of fill feature. An out of fill feature meaning that it will draw water. So this is up here is where you would have is actually where you would have your water bag, your sterile water bag, which will be drawn in by a water feed set into the humidification chamber. Now, there is, inside the humidification chamber, there is what we call a dual float system. A dual float system is which will control the amount of sterile water that will be drawn into the chamber. And when it has reached the maximum fill line, the water, or rather the system itself, will actually stop drawing any more water into the chamber. So besides that, just in going on, is if you are setting up a dual limb circuit, so you'd have the dry line into the chamber, and then you would have a heated circuit, which would go all the way to the patient through a Y-piece setup. For some, they would put a catheter mount, which is then inserted with a tracheostomy or an endotracheal tube. In this case, this is an endotracheal tube. And when the patient then breathes out, that expired gas is then taken back to the ventilator through the expiratory port, and outside it would go. Now, for this is where it's usually very common for us to see people putting a HME at the Y piece, at this piece here. So they would put a HME filter somewhere around this region. So you can imagine adding a HME with active humidification and a catheter mount. There's a lot that you've added into that circuit, and it's not common to see a lot of ventilator alarms happening, very increased work of breathing and all that. But it's also important that I mention that because of differences in circuit technologies, it's highly possible as well to be able to hit the expiratory limb as well, so that condensate management is done optimally. So this is just a setup, an actual humidification setup to show you where each part falls in as far as humidification is concerned. For reusable circuits, there are differences from the one that I've just shown you earlier and what I'm showing you now. For the reusable circuit range, these ones would basically comprise silicone circuits or made of hytrol, some materials called hytrol, and these ones are fully autoclavable. Now, full autoclavable, meaning that you can use it for up to 60 times. You know, you can use it for more and more depending on the manufacturer's recommendations of the same. The difference here being the inspiratory limb is the only limb that is heated. And the heater wires, though reusable, are actually drawn in manually into the circuit. However, it would comprise the water traps because the expiratory limb is not heated. So for the water traps, many times would require that you do discard the condensate from time to time, and that also marks a big difference between circuit technologies as well. So we do have these ranges where some would prefer using reusable circuits, while others would prefer the single-use circuits because of institutional preferences. Now, what distinguishes different models of humidifiers that you find in the market, for example? So one thing that you will find is some humidifiers would not have that control and display panel that I have just talked about. Some would lack the temperature display features. So in many occasions, you find that us as biomeds and also nurses and just clinicians in general would not really be able to know how much heat or rather what the temperature being delivered to the patient would be. And for some of these models, these are varied models, you'd find that they would have a feature that would automatically switch itself off. Now, this is very dangerous, especially when you think of patients who are highly vulnerable, like the infants or the neonates, for instance, having this feature auto switch off. Some only have flow sensor options. They don't have heater wires. However, there have been improvements in technologies and in advancement in basically humidification technologies, where you'd find, for instance, with Fisher & Paykel's, for instance, 950, you'd find that it actually has a capability of censoring patient circuit type. Now, some of the problems that we've experienced in practice is you'd find that it's not unusual where you find a pediatric circuit is being used for a neonatal patient, or a pediatric circuit is being used for an adult patient, or an adult patient circuit is being used for a ped. So you find that this is also a very welcome development in being able to censor. But also just because of cost savings, and this is a very big thing as far as our budgets in most of our hospitals is concerned, is where you'd have one circuit being able to do a variety of therapies. So it could do invasive ventilation, BiPAP, CPAP, high flow with just one circuit, and that really helps to save on costs. There have been, several models as well that have been made highly intelligent in the regard that they are able to actually hit or have two independent heating zones in their circuit technology. So if you put that circuit in an infant warmer, for example, and you have another part of the circuit being out in the open, it does recognize that it has two different environments with two different temperature differences, and so it hits two parts of the same circuit, independently. And these are just some of the newer features and modifications that you find in the newer models of humidifiers. Now, to the heart of the matter, you find that we do face a lot of issues when it comes to humidification, and it's important that we all understand how do we troubleshoot these issues. A major one is rainout, where you have water condensation in the circuits. Now, the problem with this is that when you have excess condensate, which is collecting in the inspiratory or even the expiratory limb, you find that the implication of that is that you'd have an increased risk of aspiration. Now, increased risk of aspiration would then contribute again to a cascade of events that would happen in the patient's body. It would contribute to pneumonias, for example. It would trigger the ventilator alarms. There would also be issues of ventilators having wet filters and generally increasing operational costs. So what would you do in such a scenario? The first thing to check is some steps that you can take to troubleshoot this is, what are you using in terms of your circuits? Because different circuits have different technologies that have been employed in them. Then onus then is on us to look at a circuit technology that would minimize condensation. Some circuits out here would be like some that are called evacqua, which could be a solution which heats both inspiratory and expiratory side, significantly minimizing condensation. And also you'd need to check the ambient temperature. Could it be too low? So in this scenario, you'd find that with ambient temperatures being too low, then you'd have some water forming, in the circuits, for example. You'd also need to check on the chamber positioning in terms of the temperature and flow probes. Is it well inserted? Now, for this, these are some of the issues that you would face. Looping of circuits, for example. Now, when a circuit is looped in this manner, you'd have condensate, mobile condensate that can form in the loop. So in conjunction with the nurses, and this is also very important that the nurses understand this, is that they would need to position the humidifier much lower than the patient's position, preferably at the bottom, so that by gravity, you would have that rain out, that excess condensate falling back into the humidification chamber. Others would be like on the positioning of the patient's head, for example. You'd need to check that you have put the humidifier at a lower position. This is the ventilator and this is the patient's bed. It has to be below the patient's heart, for instance, or at the base of the ventilator that you're using. Some would be no heating, or where you have a cold humidification chamber. And in this case, it would be either a faulty heating plate, or you have a chamber insertion which has not been done correctly, or just the use of non-compatible chambers. Now, this one would imply delivery of very cold, dry gas, essentially would not be providing active humidification. Several steps can be taken there. In summary, would be to check the connection of the power, inspect the heater plate, and I'll show you how it looks, and also check the heater wires that they are not damaged. This is a common problem where you find heater wires that basically are damaged and might need to be replaced. running a test cycle. Sometimes you might run this test cycle. However, different companies would have different modalities for this. So you would need to then check. For example, I'll give an example of ours is would offer a 24-month warranty. Others would offer 12 months warranty. Others would have just having their technicians have a look at it. Perhaps they have spare parts, but for Fish and Paykel specifically, it would be that we would replace it if it is within warranty. For many of our devices, we say it's built to last. However, you find that even after 5-6 years, it's working well. But in the event where a technical issue would happen, then you would escalate it to us after putting in the documents, just a document reporting format. So this is how maybe a faulty heater plate would look, and some of the alarms that it would show you in the different spots of the humidifier to just alert you that no heating is happening. Check the heater wire, for example, and all that. So this is how diagrammatically it would show you. So temperature and flow probe errors is also one common one, where you'd find basically temperature sensor alarms. The steps would be you reconnect the chamber and also inspect the probes once again, check on the probe alignment as well. Now for the probe alignment, I will show you how it should sit. It should actually sit 90 degrees above the circuit itself so that it doesn't collect mobile condensate and communicate or relay wrong information to the humidifier, which might then, because of its algorithm, change certain parameters in there. So in terms of positioning of the circuits, and also the temperature probes, is you would check that it actually latches. Now, these probes do have different designs in them, so you would check that it has been fully pushed in on both sides. So this would be on the humidification chamber and as well in the circuit itself, just checking that it is in the right places. So water levels, this is also just making sure that you have water in the water bags, which would be drawing in. So you'd ensure that you'd be checking that the sterile water is one below the fill line. Please try to not have, to not manually fill in out of fill humidification chambers. There are some that just draw as much water as they require, but also just checking that as you purchase these humidifiers, you're purchasing them as a system in terms of compatibilities of the humidifier itself with its own circuit and chambers, preferably from the same manufacturer, so that it's easier to troubleshoot in case issues do arise. So for the smart display alarms, these are just several alarms that would be indicated, and some would show you issues, for example, in terms of the airway probe or the temperature and flow probe connector has an issue. Sometimes it does tell you my patient is not getting optimal heat and humidity. Please check the manual to, and in case you need to escalate, then you would then follow the steps as we had described earlier. So when you look at best practices, what are we talking about here? You want to check the basics, have the proper setup and use, and also just use manufacturer approved humidification chambers and circuits. Check that you've selected the correct mode. Now, when you select invasive mode, you're basically telling or communicating or requesting the humidifier to provide you with 37 degrees centigrade and 44 milligrams of humidity. When it's on mask mode, it would reduce that temperature to about 31 degrees centigrade, just in line with the skin temperature on the face. Sterile water management, just to re-emphasize that we use distilled water or sterile water, not saline, and no medicated fluids, as I had mentioned earlier. Now, other recommendations would be on checking of circuits. This is a recap or as well, just checking that you don't have any kinking, any tight loops, which might encourage condensate forming, and also just temperature probe care. Sometimes you find that probes break, and so you always need to be very attentive to check that you have the temperature and flow probes and the heater wires as well working optimally. Cleaning with a mild disinfectant, checking as well the type of circuits that you're using, and just regular upskilling with both the biomedical team in collaboration as well with the infection control and also the nursing team. So what do you need to look at when you are purchasing humidifiers? This is very important for us as biomeds, because we're also tasked with coming up with specifications of these devices. So several factors need to get into play when you are trying to plan for how to purchase these humidifiers. One is just to check on the clinical requirements. Who is your target patient cohort? Are you purchasing for neonatal peds or adults? Because different circuits might be required, different chambers might be needed. For neonatal patients, sometimes they might need a pressure monitoring line, for instance. So that is important to keep in mind. What therapies are you going to be delivering with that humidifier? There's a wide array that you can use with certain humidifiers that you're not able to use with others. So are you going to be doing invasive, non-invasive, or high flow like Joanne had mentioned earlier, or even low flow? What goals of humidification are you thinking about? Is it short-term ventilation versus long-term? Is your device compatible with your fleet of ventilators? Because not all humidifiers are actually compatible for this. So having the manufacturer, for example, providing you with what we call original equipment manufacturing compatibility letters, very important. What type of circuits are you going to be using for it? Confirm that it is compatible, that all the parts actually are compatible so that it fits like a well-oiled machine. Do you want to use reusable chambers or single-use chambers across the different patient cohorts? This is also a very important consideration as well. As well as that, one that is common and we forget a lot, this one is fairly overlooked, is just on the plug type and voltage compatibilities. Now, many centers, for example, for many of our East African countries where these MR850s are used, we use 220 to 240 volts. Others would be using 110 volts. Now, there are situations where there'll be an increase in cost because of needing to purchase step up or step down devices, just because we didn't, maybe voltage compatibility was not put in consideration earlier. And also just checking other things around the environment, around water supply, where are you going to source for your sterile or distilled water? Is it available? To prevent the crystallization of humidification chambers. And also just checking for other basic things that as biomeds, we also look at. Does it need mountings? Does it need brackets as well? And just how easy is the humidifier in terms of use? So it should be very user-friendly. The staff, of course, need to be trained on this, on how to set up the settings well, how to check their alarms, and how to check also on basic maintenance, cleanups, and setups as well. So all these are very important factors that you need to put in place when you are looking at it. In supply chain and servicing, are you being offered a warranty? And if not, have you been offered a list of spare parts so that in case you are not able to it's not able to be resolved, it can be, you'd purchase some spare parts, for example, for it. Do you have an availability of consumables? And this goes with, do you have local support where you are that are able to support you with whatever you might require in terms of consumables, and also just the accessories that you might need, and also just the initial purchase cost. Is there a budget for it? But cost, I love to say, is very subjective. Subjective in the sense that you have to weigh it holistically against, is it improving patient outcomes? And is it providing you with other benefits which might not be monetary at the initial start or at face value, but has it reduced your incidences of ventilator-associated pneumonias? Has it reduced your secretion-related complications? Has it reduced the patient's length of stay and all that? So you find that these are very important considerations, but more importantly, as more and more markets are getting into regulations or registration, if you are working in a regulated market, be conscious that you need to also be compliant with the regulatory frameworks that are in place, and just your hospital protocols. What practices, in terms of disinfection maintenance would be the ones that would be recommended. So I thank you very much for this, and I welcome any questions that you may have, appreciating your time as well.
Thank you very much, Fola. I think at this point we'll take questions from the audience. If you have any questions, please, you can raise your hand. I'll give you a chance to unmute and speak. And also you can just tap it in the charts. But this was a very wonderful presentation. I believe the audience have learned something new and will be able to apply everything. I know there were some comments about the presentation. Like I said, the recording will be available on the Oxygen Alliance YouTube channel. So we normally post it 2 days after the actual day of the presentation. So definitely you have it by close of business tomorrow or on Saturday in the morning hours.
Maybe you can quickly answer a question that was sent out in the chat.
Yes.
Which was around, why don't we use boiled water? I think boiled water still has crystals in it. Yes, it kills the bacteria, but that deposits that you see after a while in the bubbler, I think that's the reason why we recommend using sterile water. And also the water that people use, the water that is used in what is called when you're doing hemodialysis, it is also good for both active humidification and also bubbling. It's a good substitute, basically. So if you're working at a hospital and you have access to that water, that's also a
So just like Joanne or Frola, to just type your emails in case people have other questions, they can be able to reach out to you. But you can also, the audience, you can also reach out to the Oxygen Alliance at info@oxygenalliance.org. So it's either you reach out to the Oxygen Alliance, or if you need to directly connect with Joanne or Frola, they can just, yes, Joanne has just pasted her email. So if anything, please, you can reach out to either her, or you can come directly to us through info@oxygenalliance.org.
And also just a quick comment. There was someone who had a question around high flow, and I think we had mentioned in the presentation around talking about high flow, but given the content, we could not put everything in this particular presentation. And I think we'll discuss to see if we can make in the future, have a different presentation that's just focused on high flow and the theory, because we know it's in a lot of places, and there's been quite a couple of questions around how to get training. So that's comment for that.
All right, thank you. I think if I can check in the chart, I'm not seeing any other question, and I'm not also seeing any other hand. So I think reaching this far, I'd like to say thank you to our presenters, and I would also like to say thank you to everyone who joined the call. I know normally we do take 45 minutes with the presentation, but today we took about closer to an hour presenting, but you have been very patient. I was even worried that maybe people would start dropping out of the call, but it is very good and very nice to see that the audience actually stayed, which is something that I would like to say thank you to everyone who joined. I don't know, before I close, maybe Joanne and Frola, you have something to say, and then we'll end the call after that.
I will quickly say something and then Flora will say something. Thank you again so much for inviting us, and we really appreciate it. I think I speak for both I and Flora. We're really, really passionate about education, medical health, education, healthcare, giving the end users the tools they need. And it's not just about dumping medical equipment into places and walking away, because we've all experienced that, especially living, working in these environments. So what we're really, really trying to do better, and we are open to suggestions. So when you email, please give us your suggestions. How do we make content and resources that are better fit for biomeds? What are the questions that you have when you look at the therapies? What questions? So that we have gotten really good at making content and presentations for nurses and for doctors. Biomeds, we are really doing our best. We have a few, but not really good. So we really, really would really love to hear a bit more around what you think works, what doesn't work, what questions you have, so that we can make that the content, the educational content, a little bit better.
Thank you, John. I think before Flora comes in, as Flora is saying her last comment, there's just a question that has just come in from George. You can just tackle that one and then we'll close. He's saying, what causes low bubbles during humidification and how can we solve it?
Ooh,
so I think
that's
we
really
can take that one and then we'll close the call.
Yeah, so so the low bubbles is about the pressure. So you know how sometimes you have in the oxygen system in the hospital, if that pressure keeps blowing, the amount of force by which you're pushing through the system, through the flow meter, also reduces. So sometimes you see a little bit of bubbling. Another part is if you have not really tightened, closed the bubbler well, that means there is leaking somewhere. So it's important to really close it well. And another thing is just making sure there's not leakage within the oxygen system, leading to pressures really dropping as they come they make it into the bubbler. So those are the two things I can think about, and also really making sure you have. Another thing I wanted to mention about water, the water levels. Sometimes you find somebody has covered the water all the way, to the top, but there is limits, and each bubbler has minimum and maximum. So you need to keep it within that, because you can see there is between the space between the maximum and the top. The air needs to go through the water system and then go into that space and exit. If you have filled it out, you're really failing to do that well. So being able to keep sticking to the right water levels, closing it tight, making sure the pressure system in the system, whether it's a cylinder or a through the walls, is actually adequate. But those are some of the things that can contribute.
Thank you very much. Fola, just a minute or two before I close.
Yeah, mine is just to really appreciate all of you for even giving us this opportunity to be able to do this presentation. Indeed, it's also a very good learning platform for all of us as well, to just get in new insights and share experiences as well for, with everybody. Just to echo what Joanne said, we are quite passionate about education and would really love to know how else can we make this a lot, better and better. So mine is just to really just say thank you. Thank you so much for the opportunity.
Thank you very much. Thank you reaching this far. I would like to thank everyone for joining, and this actually marks the end of our call. Thank you very much and have a good evening. Bye from the Oxygen Alliance.
Thank you so much, everyone.
Thank you so much. See you again soon.
Sure.
Bye.
Bye-bye.